You always see this in photos, right? But the depth of it, the way the mist just hangs there, I don't even think a lens can capture this. It doesn't feel real. It feels like I've stepped into a painting. You always see this in photos, right? But the depth of it, the way the mist just hangs there, I don't even think a lens can capture this. It doesn't feel real. It feels like I've stepped into a painting.
We are building an incredible community here, and your support absolutely means everything. So please take a second to subscribe and let us keep pushing the boundaries of what this hardware can do.
We are building an incredible community here, and your support absolutely means everything. So please take a second to subscribe and let us keep pushing the boundaries of what this hardware can do.
They say you stopped looking for him, Sheriff, but he hasn't stopped looking for you.
Some ghosts are better left buried.
They say you stopped looking for him, Sheriff, but he hasn't stopped looking for you.
Some ghosts are better left buried.
Holy hell, that was brutal! 100 hours of grinding every single side quest just for this exact moment! I am never touching this absolute nightmare of a level again, man! Holy hell, that was brutal! 100 hours of grinding every single side quest just for this exact moment! I am never touching this absolute nightmare of a level again, man!
The biggest issue we encountered when using the LTX image-to-video workflow was the loss of temporal consistency. As you saw in my previous video covering image-to-video generation, relying on just a single reference image means the model struggles to preserve the original details. Faces become completely unrecognizable, genders swap unexpectedly, and objects morph into entirely different things. The solution to this is to limit the model's tendency to hallucinate by providing both first and last frame images. As you saw in the side-by-side comparisons, it completely changes the game. In the previews, all the original details of the reference images, including facial identity and object permanence, were spot on when we guided the video generation with start and end frames. Now you can finally create professional-looking videos. Well, to be perfectly honest, using a first and last frame doesn't fix the model's inherent issues with fast-paced action and sweeping cinematic camera controls. But at the very least, you can save your cloud credits for those advanced movements and use LTX 2.3 for the things it actually excels at. This is a massive opportunity for us local users. You can easily kickstart your creative journey, generate an unlimited number of Facebook, Instagram, and TikTok reels, and maybe even get monetized since you aren't spending everything on credits. Stick to close-ups or medium close-ups if you're hoping to use the model for professional workloads. Now, this actually isn't going to be a major roadblock if you're mainly going to stick with producing standard Facebook, Instagram, or TikTok reels. Another bottleneck with the first and last frame method is that it requires significantly more hardware resources than standard text-to-video or single image generations, forcing 8GB VRAM users to stick with 720p. It's not totally impossible to generate 1080p clips, but 1080p, especially when used for portrait aspect ratios, has definitely given me some issues. Take a look at this clip right here. Another issue I noticed during testing is that the model struggles to maintain continuous action without breaking down and doing strange things when the clip is longer than 10 seconds, just like in this example. Now let's talk about another important detail. I usually go with the Euler Ancestral sampler, but sometimes the LCM sampler yields better results.
They say you stopped looking for him, Sheriff, but he hasn't stopped looking for you.
Some ghosts are better left buried.
I generated this clip using Euler Ancestral, and as you can see, the people suddenly disappear just so the model can stay true to the last frame. However, switching to the LCM sampler fixed the issue. Here, the people naturally walk out of the frame to bridge the gap between the first and the last image. Another thing you need to pay close attention to is that if you have a background where people are doing the exact same thing in both your first and last frames, like you see here, the background effectively becomes static. This happens even if you explicitly give instructions in the prompt to make them move, especially when using the Euler Ancestral sampler. Here, the LCM sampler smoothed this out a bit, but not entirely. So make sure the background extras in your last frame are doing noticeably different things compared to the first frame. Now take a look at these comparisons to get an even better understanding.
I told you this old girl would make it. I told you this old girl would make it.
The world expects you to match its chaos, to run at its frantic speed. But real power isn't about joining the noise, it's about creating your own stillness. The world expects you to match its chaos, to run at its frantic speed. But real power isn't about joining the noise, it's about creating your own stillness.
I told you it was a setup from the start. But you just had to see it for yourself, didn't you? I told you it was a setup from the start. But you just had to see it for yourself, didn't you?
Everyone said this market was tapped, that we were fighting over leftovers. But the final projections tell a different story. We aren't following anymore. We are leading.
Everyone said this market was tapped, that we were fighting over leftovers. But the final projections tell a different story. We aren't following anymore. We are leading.
I generated all the clips in this video using my RTX 5060 laptop with 8 gigs of VRAM and 32 gigs of system RAM. I'm running Python 3.12, CUDA 13.2, and the latest NVIDIA Studio driver. Here's the workflow mapped out, and you have the links to all the models right down here. Now, my preferred version is the FP8 model since I'm on the NVIDIA Blackwell architecture. If you're on an older architecture like Pascal, Turing, or Ampere, it's highly recommended to use the stable GGUF models. I have added the UNet loader node right here, in case you want to use the GGUF version. Just enable it and connect it straight to the Power LoRa loader node right here. Down here, you can choose either the Euler Ancestral or the LCM sampler. Simply connect your preferred sampler to the sampler input on the Sampler Custom Advanced node. Over in this section, you can select your resolution, clip length, and the frame rate. If you want an in-depth breakdown of how this workflow operates, I explained everything in this previous video, so make sure to give it a watch if you're trying this for the first time. If you found this workflow guide helpful, please smash that thumbs up and drop a comment down below. Thanks so much for watching, and I'll catch you guys in the next video.